prove that quadrilateral EFGH has at least one diagonal parallel to the side of parallelogram ABCD, given that the area of quadrilateral EFGH is equal to half of the area of parallelogram ABCD. Area of triangle AEF equals half AE times AF times sine alpha. Area of triangle DHE equals half DH times AD minus AE times sine pi minus alpha. Sine pi minus alpha equals sine alpha. Area of triangle CGH equals half times AD minus BG times AB minus DH times sine alpha. Area of triangle BFG equals half times AB minus AF times BG times sine pi minus alpha. Sine pi minus alpha equals sine alpha. Area of parallelogram ABCD equals AD times AB times sine alpha. Since area of EFGH equals area of parallelogram ABCD minus area of triangle AEF minus area of triangle DHE minus area of triangle CGH minus area of triangle BFG equals half area of parallelogram ABCD. So area of triangle AEF plus area of triangle DHE plus area of triangle CGH plus area of triangle BFG equals half times area of parallelogram ABCD. So half AE times AF times sine alpha plus half DH times AD minus AE times sine alpha plus half AD minus BG times AB minus DH times sine alpha plus half times AB minus AF times BG times sine alpha equals half AD times AB times sine alpha half on the left-hand side of the equation and that on the right-hand side of the equation cancel. Sine alpha on the left-hand side of the equation and that on the right-hand side of the equation cancel. So we have AE times AF plus DH times AD minus AE plus AD minus BG times AB minus DH plus AB minus AF times BG equals AD times AB. By expanding some of the terms on the left-hand side of the equation, we have AE times AF plus DH times AD minus DH times AE plus AD times AB minus AD times DH minus BG times AB plus BG times DH plus AB times BG minus AF times BG equals AD times AB. DH times AD and minus AD times DH cancel. AD times AB and AD times AB cancel. Minus BG times AB and AB times BG cancel. So we have AE times AF minus DH times AE plus BG times DH minus AF times BG equals 0. The first two terms have a common factor, AE, so we can write AE times AF minus DH. The last two terms have a common factor, BG, so we can write minus BG times AF minus DH. This equation can be written as AE minus BG times AF minus DH equals 0. Case 1, AE minus BG equals 0. So AE equals BG. Thus, EG is parallel to AB. Case 2, AF minus DH equals 0. So AF equals DH. Thus, FH is parallel to AD. Case 3, AE minus BG equals 0. AF minus DH equals 0. So AE equals BG. AF equals EFGH. Thus, EG is parallel to AB and FH is parallel to AD. Hence, quadrilateral EFGH has at least one diagonal parallel to the sides of parallelogram ABCD. The proof is now complete. Thank you for watching. Hope you found this video helpful. Please subscribe to this YouTube channel for notification of new videos. See you next time.